Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 81. Whoops. Number of distinct voice sequences. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one, I think the observation is just that the biggest one is that the gap of the biggest gap that you can do is of size 2. That means that you have to keep track of the last two numbers. Um, and that's pretty much the idea, right? And after that is just kind of brute force slash dynamic programming or memorization, depending on how you did. I actually spent 11 minutes here, but to be frank, I probably should have gotten this in about 4 or 5 minutes. I fully would expect myself to, but I think the two things, right? One is that I actually implemented bottoms up, which I still did in about like 6 minutes versus 4 minutes. Like I probably could, if I did top down, probably could have done it in like 2 3 minutes, to be honest. But I was worried that if you look at constraints, the constraints are 10 to the fourth, and it was, and we do the math, it's like about 2 million, 3 million operations, something like this. And in Python, especially if you do a tops down, I would be worried and I would be scared. And in the past, I have failed due to that reason many times. So yeah, so I was very concerned with that one. And then I had to do it bottoms up, and bottoms up is fine. But then I misread this also, to be honest. I'm just doing some analysis here. We'll go over this thing in a second. So yeah, the I actually did not. I thought this was a gap of exactly two, meaning that you can, So I actually misread that part once So I actually, I think I was trying to be going too fast, and because I misread this as two exactly, I didn't even know that I didn't know how to debug it until I was just looking at I think here, and then I was like, oh, things are not matching up, and then I had to read the problem again to see that I missed that it was at least two, not exactly two, and that basically cost me 4 minutes. And then the extra 5 minutes is that I forgot the mod. I mean, the forgetting the mod is actually pretty bad. Usually, there's a reason why you forgot it, but for me, to be honest, I just didn't test very well. If I took an extra, I rushed it a little bit. Mostly, I think because well, one is I just never read it in the beginning. But if I really thought about it for like 2 seconds, I should have caught it. But instead, and also if I just wrote, if I test 10 to the fourth, it would have been very obvious that it would have overflowed it, right? So I really should have been able to catch that. But I rushed it because I think it's one of those things where, because I made a silly mistake earlier on, I think in my mind I'm like, oh, I gotta get this faster. But then because I tried to do it faster, I just missed like testing, and it would have cost me like 10 seconds of testing, and instead it cost me 5 minutes of wrong answer, right? Anyway, let's go over the actual problem. So those are kind of my analysis of how I should have done it better. Maybe I could have done it in the other order. Sometimes I do analysis in the other order, but just to kind of give you a sense of how even I could make mistakes, and I took 11 minutes when I probably should have 11 minutes plus 5 minute penalty when I should have done it, and maybe closer to 5 minutes even bottoms up. But if I did tops down, I probably wouldn't have made any of these issues because I would focus on that part instead. But Leetcode has been kind of I think Leetcode has been an issue lately, and so yeah, because at least in Python, it's not super clear that top down is good enough. But I'm gonna go over the top down solution, and then I'll go over the bottoms up solution. And this is actually gets accepted. So yeah. So the first thing I do is I pre-calculate the GCD goodness function. This makes it a little bit faster. I think actually maybe this actually even makes it fast enough that I could do it top down, but I didn't analyze it this way, so I wasn't. If I did it that way, maybe it's a little bit faster because it's about 50% faster. Because if you did, because instead of 36, two loops that makes 36, this allows this to become only a loop of 22 elements, right? Yeah. So. Maybe top down is faster because I skip a lot of impossible things. Oh well. But in any case, yeah. Um, and because of this, this just makes it all one lookup instead of doing GCD and stuff like this. So this is a little bit faster. Um, yeah. And then here, P1 is, let me just write it out. P1 is equal to 2 values ago. P2 is equal to last value. And the reason why we have these two is pretty straightforward, is that we need the last value to look at, and then we brute force from 1 to 6, the last value, whether it is good, right? If it's good, then we use it because it means that it's not Leetcode and it's not GCD. Yeah. I think, oh yeah, the tricky thing about, so why does the gap of 2 matter? I think maybe I also thought about this a little bit, because the GCD of every number will be itself, right? Or like every number with itself is itself, except for, well, I mean, it's still true, but so you cannot do 1 and 1 together, because the GCD of that is equal to 1, but they're the same, so you have to remove it, right? So basically that changes the number of sequence from 23 to 22, and that's why I have this if statement. But yeah, but basically, yeah, 2 values ago, and then you just basically follow the rules and do it kind of brute force, right? So one is that 2 values ago, this is basically making sure that the values don't, there's still at least 2 space gap. So if it's the same as that value, then you just skip it. Otherwise, we make sure that this is GCD is good, and of course we check the Leetcode as well. And that's basically the idea, right? We brute force. Yeah, and then for each index, and then we just remember the mod. I actually forgot the mod because, like I said, I really should have just tested n is equal to 10,000. If I did, oh well, let's just say I removed the mod, and this is not quite what I submitted in the beginning, but you can see that, I was like, if I had just tested this, I'll look at this, I'll be like, oh, there's no way this is right, just for sanity check. So then I would have added the mod back, so it would have cost like 20 seconds the most, right? So that's a little bit sad, but yeah, I just didn't even see it. Usually I'm really good about seeing this, but today maybe I'm just a little bit off with this one, and it cost me 5 minutes. But yeah, just mod, and that's pretty much it. Yeah, so what's the complexity, right? Well, P1 is going to be from 0 to, I wrote it from 0 to 5 and then added 1 here, as you can see, but you can do it in either way. Either way, it's going to have 6 possible values, and index, of course, can go from 0 to n, and so this is n possible values. So this is just going to be O of 6. So yeah, so what's the time complexity, right? Is equal to time per input times number of input, right? Number of input is equal to O of 6 times 6 times n. Maybe we could write D for the number of dice spaces, and each input takes O of D time, as you can see for the 6. So this is going to be O of D cubed times n for time, and same idea except for each input takes O of 1 space, so this is going to be O of D squared times n space, and that's pretty much it. And we feel the math it gets close, but keeping in mind that a lot of these inputs are not actually possible, even though it is in theory possible, but it's not actually possible. What I mean by that is, for example, you would never call go 225, right? Because that means that the 2 previous numbers have a GCD, or the 2 previous numbers are just the same, right? Which is or against the rules, but so this will never get called. So you can eliminate a lot that way as well, which is probably one of the reasons why this is fast enough as well, but I didn't really think about it. Instead, I convert this to bottoms up, and you can kind of see this here. Yeah, and this is, I'm not going to go over this solution. This is the same solution, except for that I did some pre-calculation differently, and I did for loop differently. One cool thing about this is that, let's just say we have this as the space, right? No, this is I can't write it. This is not the thing. But yeah. So one thing about this is that you can actually use space optimization for it, is what I was going to say, and you could do this in O of D square space by because you can see that on the last dimension it is just looking at the previous element always. So yeah, so you can do it in O of 36 space or D square space, for example. Yeah, that's pretty much all I have. Let me know what you think. Let me show you this one and then this one. Again, the reason why, so I this is the one that I submitted during the contest because I was very sketchy that this one is fast enough, but apparently it's fast enough. If I was able to know this, I would have gotten this in like 2-3 minutes the most, to be honest. Maybe 4 if I maybe a little bit longer if I make the same mistake about this. But I would have been more focused, and maybe I wouldn't have missed the mod because I had so much, like I wouldn't be rushing it. But I don't know. These things are always tricky, and sometimes one silly mistake costs you 10 minutes of penalty, and it takes you from 15 minutes to 25 minutes, and then just adds up. Anyway, you could watch me solve it live during the contest now. I also actually wrote it top down in that section as well, so check that out. Yeah, do now. You're already done. Okay. Distinct subsequent greatest GCT is 1. Okay, what does that even mean? N could be very big, so probably fine. So last 2 numbers, right? Last 2 numbers 36. Okay, fine. Mm, 36, 36, 36. What is that? Just to make sure. Should be okay. How do I even? Oops. Is that right? I'm spending time on this. Right, that feels about right. Let's see. There's 2 numbers ago. Why did I do the indexes this way? Well, too late. That is not close. Or maybe I triple count? No, more than triple count. 184. Okay. Let's see. 1 is 21. That's not right, right? Oh, there should be n minus 1, I suppose. 1 is 3 is 66. 2 is 20. I'm off by 1 on the 2. It's 2. Two numbers. This should be right though. Why is this wrong then? Huh. This is not a hard one, but I'm mixing it up. If I'd done it the other way, it would have been easier, but I'm messing up my base cases maybe. I was worried about time limit exceeded. But also this is just not good. I guess I don't need this technically, but still. So this is. Oh, I'm dumb, am I? This should be. I meant to do this, but I forgot. Okay. It's still wrong, but at least it's wrong in the right direction. Maybe. I forgot to do a +1, that's why. Why is this wrong? The previous ones are J and K is good, K is not equal to I. Why am I overcounting now? 6 is good, so one N. Common divisor, yeah, okay. 6, 9. 23, right? So what am I missing on? Oh, at least a gap. Okay, I think I messed that up. Okay, fine. That's fine. That's fine. Oh, I misread that one. Okay, that looks good. Click submit. At this time limits, I'll be ready set. Maybe I should have done it in C++. Oh, Did I forget the mod? I forgot the mod, didn't I? Oh man. I didn't actually, I don't think I ever read the mod, but then I just makes sense that there's a mod on this one. Yeah. It's just I was so focused on silliness. If now time limits exceeded, I would be very sad actually. But that was kind of sad. I should have gotten that one faster. Q4. I think if I had done it with I actually, yeah, I just didn't think about that one because I knew how to do it almost immediately, and I got distracted by the implementation because bottoms up is a little bit harder for me, and then I just forgot about the mod. I just never read it because usually I do the mod song. I just didn't read it perfectly, and I didn't really think about it because I did rush a little bit because at the end I was too worried about time limit exceeded that I didn't look at the mod. If I did, then I mean I don't know. It's just I didn't do it. I wish I wish they'd have one example that where the mod is needed because that wouldn't have given anything away. Right? Like even n is equal to 20 would have been it, but I mean, but that's maybe my fault. So it's fine, sloppy. Let's see. Maybe this contains China, and so I don't know where I am, but this isn't a hard one, so I imagine a lot of people did it very quickly. Surprised Josh didn't finish it yet, actually. But this is also maybe lagged, so maybe he did finish and it just doesn't show up. But yeah, I'm gonna actually see if I could upsolve this just for fun, to see if I could have done it tops down because that's what I wanted. I think this is my more inclination to do it, but to do it this way. But we'll see. Let's see. If index is equal to n, we return 1. Otherwise, for I 6. Let's see. And we could even do something like right. So then like good is equal to 4 times 6 for right, and now good of ij is equal to true. So we pre-process, and then now we have let's see, if good of from p2 to I, oh yeah, and p1 is not equal to I, then go of p2 I index plus 1, return total the mod. Can't believe I forgot mod. I mean, I just didn't really think it through. I mean, it's very obvious, but I just didn't. Right, something like that. Is that right? Nope. It's something. Am I under? Because I am under. I did this very quickly, so. Oh, this is a little bit awkward. It's in P2, but maybe try. Kicking it off is a little bit awkward. I thought this would work, but maybe not. But something like that would be fine. Yeah. Okay. I wonder if this is fast enough or time limit exceeded, because that'll be very sad. I guess I should have done it that way, because I would have got. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's contest, today's problems, and all this stuff. Yeah, stay good, stay healthy, to good mental health, stay safe out there. I'll see you later. Bye bye.